Hello world, welcome to Sphinx channel. Before we start, if you like this content, please subscribe to my channel. If this video was useful to you, like it and tell me your opinion in the comments. Well, let's start. So today we'll be discussing about nmap, a network mapping tool that can help us discover services, ports, devices inside your network, in or out of network, and be able to find out more information about them. And we'll be going through some of the options and parameters that could be part of nmap. And also we'll look at scripting capabilities. And ultimately, how do we use it in a penetration test? How do we do it during a security assessment using nmap? So before we go into nmap, we want to learn about what is banner grabbing. So banner grabbing is actually probing the service, probing the device, looking for specific information on the port number. So in this case, if you see on the right side, we are trying to probe a specific target on port 21 and it says that file transfer protocol is open. So this gives us some details about the port, about the kind of service that's available. So you can think of this as an analogy of going into a house. So before you go into a house, you want to see what kind of doors they have, what kind of services are open for it. And of course, when you knock onto the door, you can see that. Perhaps this is a restaurant, this place is a place that provides services for laundry. So again, you're trying to find more information by probing into the house, looking into the house, knocking onto the door, finding out more information. So likewise, on the right, again, we can see we are probing a port 80. So port 80 hypothetics transfer protocol, we see that it's open. So the port is open. Once again, so this is a way where system administrators actually try to take advantage of the kind of services and systems that are available inside a network. All the houses in that lane, what do they offer? So again, this is a way of us using banner grabbing as a start. And of course, this also brings us to another fundamental about network, about services. So on the left side, we can see the kind of messages we have. So we have sing, we have acknowledge, we have sync, acknowledge as well as finish. So the description of sing is trying to establish a connection with another device from your browser to another computer, from a computer to another computer. And of course, acknowledgement comes in effect when another device replies to you, acknowledging the service, and ultimately you sync and acknowledge. And this gives us a chance to actually start the connection. And ultimately, if you want to terminate the connection, you send a finish message into the other device and that will close the connection immediately. So over here, this is the three-way handshake. So the tree handshake. So you see, on the left side we have computer A trying to talk to computer B, so it would do a send off a sync message and the computer B will reply with a sync knowledge and an acknowledge will be responded from computer A to computer B, so this completes the three-way handshake and it establishes a connection between the two computers to start exchanging messages. So this is an important concept because this helps us visualize what happens behind the scene of nmap. How is map probing and telling you how a port's open and what to do in order to find out if they are open. So some key terms. So on the right side we got transmission control protocol. So this is connection oriented. So this is a place where the trivial henshaw occurs and we are able to actually look at the stable connection between two computers. And we've used the datagram protocol, which is connectionless, so it is a way of fire and forget of packets. And this actually just sends a lot of data to the other computer without checking whether the connection is stable. And ultimately we got what we call socket. Socket is IP address followed by the port number. So this allows the opening of a particular service from a machine so that you can actually connect into that particular service. So what is map? So map is a network mapping tool. It's a network exploration tool, helps us find out a lot of information about the network, and it's really useful to not just the network, but also the devices within the network by scanning their ports, looking out for what kind of protocols they're running on. So that's a great way of trying to find out what kind of services is available on the network. So there's a number of scan types. So of course on the right we can see 6 major scan types. So the first one is swipe, where we actually send ICMP pings, which are the way for us to ping devices and see whether those devices are alive, whether they're reachable or we able to reach them. And the second one is trace. So trace is using trace route to actually find out how the packets are being sent across the network into ultimately the computer that we want to reach on the destination. And then we have port scanning. So port scanning, check for open TCP or UDP ports inside a computing device, and a computing device could be an email server, a database server, a web server, could be a generic general server. So again, we are trying to find out all the services available. So on the bottom we got fingerprinting. So, fingerprinting determines the operating system type. Is it a Linux? What version of Linux is it running on? If it's a Windows server, what kind of version of servers is it running on? Is it a notebook? Is it an Android device? So again, we're trying to find out what operating system is that particular device through them as well, and we have version scanning. So version scanning actually help us find out all the services and protocols that are used inside the system. And of course we will have demonstration of how we could find out all of these scan types later on. And on the most right bottom we can see vulnerability scanning, so we can also use nmap to actually do vulnerability scanning. So if you look up on the previous tutorial, we were using Metasploit to actually scan for vulnerabilities. And of course in this case we can use nmap as well to do those vulnerability scanning to find out if those services are vulnerable by checking against common vulnerability exposure database. So again, these are the 6 key functions that we can use for scan types in nmap. So of course, after you perform the scan, there will be the port states that will actually be provided to you after you completed the scan. So on the left we can see on this table we got open, closed feuded, unfeuded, open fielded and closed feuded. So if the port is open, we will be able to see that the application is accepting TCP connection. So if you think about how we were doing the three-way handshake, so whenever we send a sync, we'll get a sync acknowledged back telling us that the port is open up for us to test on. And for the second role, we can actually see it's closed. That means when we send a sync message into that particular service, we may not get a response coming back, or whenever we are sending or using auto-scanning techniques, we're not able to see if the port is open inside the device. And we also have filtered. So again, filtered could be because there is a firewall in between it. So if we're scanning a web application server, there could be a web application firewall trying to restrict the kind of scanning that we could do inside the firewall or inside a web application server. So, again, a firewall standing in front of it, trying to protect it, and if we're scanning a database, so again, a database could also have a firewall, and again it could be a network base, could be a host base. So again, it's trying to filter out many of these potential scanning techniques that could actually otherwise show them the version of the database, the version of the web application service, all the services that are available as part of the server. And of course we also have unfiltered, so the port is accessible. However, the scanning result is not able to determine whether it is open or closed. So again, this is another way where we may have to start looking at using some other tools to help us finally aggregate the results from all the scanning tools and from all the scanning techniques that could tell us what state is that particular service inside the server. And we have open filtered. So over here the emplaces port in this state is not able to determine whether the port's open a filter. So of course this happens when you are scanning the open port that gives no response. So again, we may have to start using different kind of scan techniques to ultimately get back a positive result, telling us whether that particular service open or not. And finally we got a close filtered. So this is when nmap is not able to determine whether the port is filtered or not. So again, we can also look at some of the auto-scanning techniques to help us further progress our penetration testing in terms of information gathering. So the first thing we do is to constantly look up the manual page or the documentation of nmap. So this is the place that we'll be using a lot, especially when we try to understand some of the searching parameters or options as part of nmap. So this is the number one place that we'll go into, and you could be spending hours every day trying to read up, understanding the options, and trying to test out all the different options on your servers. So this is number one place that we'll be referencing a lot of our scanning from. So when you look at map through the manual page, we can see a number of scan options. So the first one you see is a target specification. So this is the part where we are trying to tell map if we are scanning a particular host, the host name, a range of IP addresses, what type of networks. Or we can include files to actually look up the whole list of IP addresses that we want to scan against. So over here, this is a result of scanning using map. So here we can also see in terms of host. discovery, so we are using on the right side, if you see. From the screenshot small s, n, and of course this is where we indicate ping scan, so this is a disabling of port scan. We just want to quickly find out if the hosts are up. So again, you could also use another tool called net discover. And again, a lot of this could be using just the ICMP ping to actually reach to the host and find out if the host is alive or not. So this is a very quick way to find out the IT devices within a particular network. So on the left side we can see the full list of the options that we can indicate. So again, we have the skipping of host discovery, we have a list of targets that we can indicate to nmap and of course we also can see ICMP echo, so we can change some of this discovery request probes, and of course we can also disable the DNS resolution. So if you saw from one of the earlier lectures we were looking at domain name servers, resolution solution, where we have a list of IP addresses and a list of domain names. So again, those could take time because you need to probe the DNS server to get that list of the IP addresses and the associated list of domain names. So again, we can disable that so they can speed up the whole process of scanning. And of course the last item is on trace route. So trace route allows us to see how the packet is transiting inside the network from one device to another. So another great way for us to find out in terms of host discovery. So of course, moving forward, we have the scan techniques that we can indicate as part of nmap. So if you saw earlier, you can see from the second bullet point we have a small s with a big S and we got small s and big T. And so on. So we got TCP scan or TCP sync. So if you saw earlier from the three-way handshake, so we only be using the TCP sync when we're using the nmap technique, or if you want to use the connect scan to acknowledge the window, they may want scan. So again, all these are the options that you have. And of course on the third bullet point you can see a small -s followed by capital U, so that's a UDP scan. So user datagram protocol scan. So we are only scanning for services that could have UDP up and running on those machines. So of course we also have many other scanning options. So, again, we want to use all these different kind of scanning techniques extensively. Get familiar with it. Try out all of the options as you're doing the tutorial, so that you understand how the scanning techniques work, how it will affect the response coming back from the servers, from the devices in the network. And you can also use these ways to find out if there is a network intrusion detection system or prevention system by throwing out all this different combination of packets into the network and seeing the response from it. So here we have a port specification and scan order. So over here on the left side we can see a screenshot indicating P1 to 65,535. So we're scanning from port 1 out of way to 65,535 and we're targeting a particular IP address. So of course, on the right side, we can see what kind of modes we can go into. So we go to capital F on fast mode. So we will scan fewer ports than the default scan. And of course, we go -R. So again, you can actually read through into the manual page what constitute fewer ports, what are the key ports that will be scanned as a result of using that option. So all these are key things that you want to read up in the manual page, so that you can understand further about how you can use map. So we can also look at the top ports, so commonly used ports, so you can think about the commonly used services inside a server, so chances are FTP, HTTP, SSH, SMTP and so on. So there's a huge list of those commonly used ports that we can scan only to find out if those critical services are running inside that particular server or machine. Moving forward, we also have the service version detection on the scan options. So in this case we are using a small s followed by a capital V, so this would actually describe all the services in details if it could get against the signature or the list of signature when we are probing or doing banner grabbing into all of those services. So this is one of the ways map is working, trying to find out what are the specific version of services inside the computer and machine. So if you actually go back up from all the service results, so over here, this is going back up a slide to slide 13. We can see all the services, but we are not sure what is behind the service. So what kind of secure shell version is it running on? What kind of SMTP server is it running on? The mail server that is running on. So all these are key questions that can only be answered as part of capital V. So this is service version detection, and of course we also have the version intensity. How intense are we going to try to find out the version number inside each of those service? And of course on the right side we can also increase the verbosity or show the detailed version scan activity, so we can see exactly what kind of information is being sent from nmap all the way into the particular target machine, and we can find out more from there. So we also have a script scan. So script scan is going to be expanded later on during our tutorial as well as the later part of the lecture. So of course we have multiple user scripts. So scripts are a way for us to actually make map a little more flexible and versatile. So there are a lot of scripts being written by developers out in the market. So what it does, there could be many different kind of scanning. So it could be scanning a particular service, it could be trying to find out a particular HTTP port and trying to find out what service is it running on, as well as other many capabilities and functions. And we can also put in arguments if that particular script takes in arguments to check whether we want to further extend the features and functions of controlling the modules as part of the scripting engine or controlling the script as we're doing the scan result from it. So here we got operating system detection as part of the scan option. So if you see on the left side, we can actually see that the operating system details Linux 2.6.92.6 treatery. So again we can enable OS detection and we can find out what is the operating system type. So if you go back to the previous tutorial on Metasploit tutorial, we could actually see that we need specifics, especially on operating system type as well as the software version. And then we'll be able to find out if we can actually do the lookup on the common vulnerability exposure and be able to find an exploit for it and be able to hack into the system. So again, always detection is going to be key also in terms of finding out more details about a server, about a particular device that we're scanning into. And of course on the right side we can see the options that sometimes you may not be able to actually find out the operating system type. So that is when you may be using the OSCAN guess. So again we are trying to guess the operating system more aggressively from the use of that function. So there are also timing and performance control that you can actually input into. So a lot of times, if you're scanning in a production network or environment, chances are they have security monitoring platforms like network intrusion prevention systems, like a CM. So again, all this could be running in the system, running in the background, as well as host-based detection and network-based detection, all working hand in hand, trying to find out when their attack is incoming. Someone is doing some aggressive scan, someone is doing stealthy scans, and so on. So this is the part where you want to control how quickly you're scanning the network, and you can actually indicate the amount of time taken to actually scan a service, the particular time taken to scan all the network based on the parallel host scan group sizes and the amount of parallelism that you are scanning on the system. So again, great way to control how you want to scan a network if you know they're running some kind of products or technology that is used on the defensive end. So at the same time, like we mentioned earlier, there could be firewall intrusion detection systems. So we are constantly trying to evade them while getting all this information about the server, about the devices. So, over here on the right side, we can actually fragment the packets. So that's one quick way, because whenever the packets go through the firewall, they would actually do a state for filtering. They would check the particular packet so you can break it down, fragment it into smaller and smaller fragments, make it more and more challenging for the firewalls to actually be able to find out what kind of information is coming in on. And you get a $D, so that's a decoy scan. So again we can push up decoys in the network trying to fix scans on it, so that could be another way. And we are also able to spoof the IP address of where you're scanning from. So again, this is the spoofing of the source IP address, so you could actually augment and change those results coming in again. And of course we can change different kind of interfaces, so you've got different kind of network interface cards or different IP addresses. You can use this to actually change the network interface on it. And of course we can also change the port number where we're coming to scan from the source of the port scan. So again, all these options have to be set inwards so that we can actually control the result in a response coming back from the system, trying to evade all this firewall intrusion detection system. So we also have the output and capability of outputting more information as part of the MMF scan. So -V on the left, as you can see from the screenshot. So that is one way for us to open up more details about how the scan is going and what kind of scan result is it coming from. And of course on the right side we can see all the parameters, so there's a lot of different kind of output that we can put into the system. So one, we can have XML, so XML format would actually give us the rows and columns of the results coming out, and of course we can increase the velocity. In this case we're using V on that. And of course you can look at decreasing the debugging lever or double D on that to actually look for greater effects. So again, multiple ways for us to actually look at the scan results. What kind of package is being sent? What kind of parameters are they using as part of the scanning? And of course we can look at some arrows. So if we're using from the scan and we could not detect a particular part of the service and we're very sure it's running, so again, we want to increase the velocity on those checkings. Of course, we also got the miscellaneous scan options. So if you are running on an IPv6 network, so you could use -6 on that. And of course, we could use -A to enable a number of options like always detection, version detection. So multiple things could be enabled at one shot. And of course, we also have data file location, and we got the use of raw internet frames or IP packets. So if you want to craft those, we can actually go ahead and do that. So again, -H, very important way for us to actually print a summary page. Again, we want to constantly look at the manual page, especially when we are using it for the first time or the first few times and we're confused about some of the options. So the manual page is going to be a great place for us to reference a lot of all these materials from. So nmap scripting engine, NSE, is a great way for us to actually include scripts from nmap to actually run more extensive features and functions that could be outside of what we saw earlier on the slides, understanding more about nmap. So there's a lot of extensive functions that we can actually look into by deploying all these additional modules of scripts into nmap, and we can run them extensively. We got the major script categories on the left side. We got authentication, broadcast, brute force, and many others. Of course, on the right side, if you have Kata Linux or if you have nmap installed into your system, you just go into USR share nmap scripts, and we can actually do a listing of all the NSE, all the nmap scripting, and we can actually see over here we got checking on FTP, checking on HTTP, checking on MySQL, RDP, RSA, Sambar, and so on. Great way for us to check if a particular service is vulnerable to a CVE, or check if we could exploit into the system, or check if we can do a brute force attack directly into the system. So again, great ways for us to explore further features that does not come along the default core of nmap, but to expand upon it. So great way to look at scripting on this. So here we are looking at an nmap vulnerability scan. So we are using a -S followed by capital V followed by ~script equal v1er. So again, ~script equal. This is the part where you include what vulnerability scanner or what script you'll be adding as part of the scan, and finally with the IP address. So the function of this script actually help us associate what service you're running on for that particular device and what potential CVE, common vulnerability exposure database item or ID it may be associated with, so that we can look it up. And if you think back about the previous tutorial Metasploit, we could actually do a connection between the CVE numbers here and checking it back on Metasploit to see what potential exploits are already in Metasploit. If not, can we load it in? And after we load it in, are we able to run and execute the exploit against the system? So as we're doing the information gathering, active information gathering, through nmap, this is one of the great ways to actually be able to find out what's going on and be able to plan our next step in the penetration testing. 3 great references. There are a lot of options in nmap that you may not have not familiar with. Here are 3 great sites that you want to look into to help you understand more about all these options. Different scan results, scan techniques that you can combine as part of your information gathering, as part of using the scripts inside nmap. Again, great reference point. Finally, the question on hacking with nmap, is it possible? Yes, based on the scripting technology that comes with it. Can we do a login? Can we do a check on the system? Can we exploit into the system using map? Again, we are able to explore in it, and we are going to see it also inside the tutorial right now. On the left side, I have a virtual machine running so I can enter ifconfig and we can see the IP address of 192.168.1085. This is the target IP address, and of course, we also got Kato Linux running so I can open up terminal and we can zoom in a little so it's easier for you to see. Of course, the first thing you can do is actually enter man nmap. This would actually boot up the manual page or the reference guide of nmap. We can tell it is an open source tool for network exploration and security auditing. As we scroll down, we can see the different examples of an nmap scan. We can see the different options summary. Here we got target specification that we went through, host discovery, scan techniques, pod specification, service version detection, script scan, OS detection, timing and performance, firewall ideas, evasions and spoofing, and so on. Again, all of these options available and described very well here in the manual page. Anytime you don't remember what is the purpose of the option, you go back into the manual page and search it up. Moving forward, we can look at the scan result over. Here, we actually did an nmap, so we can do nmap-sn followed by the IP address of 182.168.1.024. What we are doing here is we are scanning the entire network for the host of devices that are open. Up, when we hit enter on that, /24 is actually the subnet mask. We are actually indicating the scanning across all of these devices. We're scanning the full IP range of devices inside the last class. Here we got 192.168.1.0. We are scanning all the IP devices on the last one. Here we can see whether the host is up as well as the IP address of the host. We are not doing any port scanning inside those IP devices. This speeds things up. Here we can see 256 IP addresses completed in 16.09 seconds. Moving forward, we also got a scan option on the pod specification and scan order. Here we can actually look at map and we can actually indicate map 192.168.1. For example, we are going after 85 and then we can indicate the port numbers that we want to scan into. I can zoom in a little on the right side on the lecture slide that you saw earlier. We actually use a -P1-65535. This was scanned across all the ports inside the IP address. Again, over here we can see all the port responses and the services associated with the port numbers. We got file transfer protocol, secure shell, TLint, SMTP, domain, and so on. Again, we're thinking about some of these options. What are the commonly used port in the server and how could you actually identify them, perhaps using an art of tackling as well other than map. Moving forward, we also got a -SV. Again, this is another way for us to actually find out more details about all the services inside the particular IP address. When we hit map-SV followed by the IP address, all the domain name or the host name on it, we can hit enter on that. This would give us more details about each of the service that is running inside the system, meaning that we can find out specifically what is the version number of each of this service, and we can actually do a lookup from CVE, for example, or from metasploit, or from searchsploit, and we can find out whether there are vulnerabilities inside each of these services. Here, we can find out a lot of information regarding each of these services, and we can see the version details. And again, all these really help us accelerate the pace of finding potential exploit, looking for vulnerabilities inside the system. And the next one we can look at is of course, the -O, so this would actually enable the OS detection in the system. So for example, going back here, all I got to do is do a -O, hit enter on that, and it would scan the IP address. So it says require root privileges. So you can enter S2D0 and it will ask you for your password. So you just key in your password for your user account. Hit enter on that and it would actually scan, including on the end of the OS detail. So here we got the OS detail, Linux 2.6.9 to Linux 2.6.33. So, again, this is another way for us to look at what operating system it could be running on. So over here we got a scan option. Here we got the -V is in terms of velocity. Again, we can indicate all this information to actually find out more details about how map is faring across in the process or in the process of scanning with a particular IP address. Again, if you do a double -V, again, we could have different results. All these are different ways for us to find out more details about the scanning, how the scanning was conducted, or if we can actually look at the debugging function as well, we can look up more information on this. Over here we do a "-D again, we can see connection refused, and we can look at more information as we scroll up, so maybe we can actually see for some of the connection accepted. Here we can see, remember from the slide, sync acknowledge. Again, we see a sync acknowledge saying that the port number is open and we can find out more details from there. So here, likewise, we can actually go into the directory by cd_usr share, followed by map, followed by scripts and enter LSL on that. So here we can see a lot of this NSE. So all these are the map scripting engines, so we can see a lot of different kind of scripts that we can use. And of course it is not possible for us to go through the whole of this in today's tutorial, so you have to try them out as much as possible. Get an operating system, run some services on it and start doing a scan. So we got MySQL dumb hashes mount password. So again, all this could be part of the cyber attack chain. So if you think back about the cyber attack chain that you saw earlier on the lecture was that we covered extensively in information gathering, exploit delivery, some app would have some of these scripts that could actually go into the exploit phase or even dumping hashes and so on. So again, all these are key capabilities that you must explore to find out how we could actually aid you in your penetration testing. So of course the number one script that we'll look at is in terms of trying to find out what are the CVE combination of affiliation with each of these services. So over here, as we have did a screenshot, we can actually do map-sv for service detection followed by double script equal vulner. So this is vulnerabilities and followed by the IP address 182.168.185. So, hit enter on that and this would actually start scanning for all the services inside the IP address and trying to connect them back into the CV details. So that's great because it do a two job for you. One is it scans for services that are available and two, it can actually allow you to find out what kind of information is available as part of the system. So again, great way for us to find out more details about the system in question and we can actually check a lot of this information out from there. So of course the great thing about it is that you can also look up what is inside the system. So, for example over here we can scroll up and we can see, for example we got the use of SSH so it says vulnerability 2010, 2017, 2016, 2008 and so on. And of course you can actually do a cat on that. So the file is right here, so we got Vonner's NSE, so all you got to do is do a cat Vonner's NSE and we can see how the script is written and how they're doing the checking. So again, a lot of things you can write it on your own and be able to create some of these steps in advance for you, just like how vulnerability scanner script is actually being used in this case. So you find out the service number, and 2, you check it back on CV details to see if you can find those vulnerabilities.
So thank you for watching until the end of this video. Until the next video, keep cool and stay anonymous.